Welcome student. Myself S.C. Kunde from Gokhale Education Society's JDC Bitco English Medium High School, Nasik Road. Previously we have discussed pH of solutions, universal indicators, reactivity of acid and bases and neutralization reactions. Now next is reactions of acid with oxides of metals. In these reactions, the acid is reacted with oxides of metals. Take some water in a test tube and add a little red oxide, that is the primer used before painting iron articles, to it and add a small quantity of dilute HCl in it. Shake the test tube and observe. The chemical formula of red oxide is Fe2O3. The water insoluble red oxide reacts with HCl to produce a water soluble salt FeCl3. This gives a yellowish color to the water. The following chemical equation can be written for this chemical change. The equation is given Fe2O3 plus 6HCl, which is forms twice FeCl3 plus 3H2O. Next is the reactions of bases with oxides of nonmetals. Bases react with oxide of nonmetals to form a salt and water. Hence, oxides of nonmetals are said to be acidic in nature. Sometimes the oxides of nonmetals themselves are said to be example of acids. Zinc oxide react with sodium hydroxide to form sodium zincate and water. Similarly, aluminium oxide react with sodium hydroxide to form sodium aluminate and water. Here some reactions are given. Oxide of nonmetal plus base is forms salt plus water. CO2 plus twice NaOH. Now here CO2 is the oxide plus NaOH is the base, which forms Na2CO3 plus water H2O. C in the second dash plus twice KOH, that means CO2 plus twice KOH, which forms K2CO3 plus H2O, salt and water. Now try to complete third reaction. Next is the reactions of acids with carbonates and bicarbonates of metal. Now fit a bent tube in a rubber cork. Take some lime water in a test tube and keep it handy. Take some baking soda in another test tube and add some lemon juice to it. Immediately fit the bent tube over it. Insert its other end into the lime water. Note down your observation of both the test tube. Repeat the procedure using washing soda, vinegar and dilute HCl properly. In this activity, when lime water comes in contact with the gas released in the form of effervescence, it turns milky. This is a chemical test for carbon dioxide gas. When lime water turns milky, we infer that the effervescence is of carbon dioxide gas, and this gas is produced on reaction of acid with carbonates and bicarbonate salt of metal. The reaction is as follows: CaOH2 plus CO2, which forms CaCO3 plus H2O. Next topic is salts. Types of salts, that is acidic, basic and neutral salts. Prepare 10 ml aqueous solution from 1 gram each of sodium chloride, ammonium chloride and sodium bicarbonate. Measure pH of each solution by means of pH paper. Are the values of the same for all three? Classify salt based on the pH values. We have seen that salts are formed by the reactions between acid and bases. Through this reaction, this reaction is called as neutralization reaction. The resulting salt are not always neutral. A neutral salt is formed by neutralization of strong acid by a strong base. The aqueous solution of neutral salt has an acidic salt is formed by the neutralization reaction between strong acid and weak base. The pH of the aqueous solution of an acidic salt is less than 7. On the contrary, the basic salt is formed by a neutralization reaction between weak acid and strong base. The pH of an aqueous solution of such a basic salt is greater than 7. Next topic is water crystallization. Activity is given. Take some crystal of blue vitriol in 2 test tubes. Add some water in 1 test tube and shake it. What did you see? And what is the color of the solution formed? On heating, the crystalline structure of blue vitriol broke down to form a colorless powder and water came out. This water has part of crystal structure of blue vitriol. It is called water crystallization. On adding water to the white powder, a solution was formed which had the same color as the solution in the first test tube. From this, we come to know that no chemical change has occurred in the crystals of blue vitriol due to heating. Losing water on heating blue vitriol, breaking down of the crystal structure, losing blue color and regaining blue color on adding water are all physical changes. Ionic compounds and electrical conductivity. Prepare a solution of 1 gram sodium chloride in 50 ml of water. Take 2 electrical wires. Connect one wire to the positive terminal of a 6-volt battery, while connecting the other wire to the negative terminal of the battery. Include one switch and one holder with an electric bulb. Remove the insulating cladding. From 3 cm portion of the other free end of the 2 wires. Take the salt solution in a 100 ml capacity beaker and immerse the uncovered end of the bulb close only when electric current passes through it, and this can happen only when the electric circuit is complete. In the above activity, the circuit is found to be complete when the aqueous solution of NaCl, CuSO4 and H2SO4 are used. It means that these solutions are conductors of electricity. Electrons conduct electricity through electrical wires, and iron conducts electricity through a liquid or a solution. Electrons leave the battery at the negative terminal, complete the electric circuit and enter the battery at the positive terminal. When there is a liquid or solution in the circuit, 2 rods, wires or plates are immersed in it. These are called electrodes. Electrodes are usually made of a conducting solid The electrode connected to the negative terminal of a battery by means of a conducting wire is called a cathode, and they connected to the positive terminal of the battery is called an anode. Next topic is dissociation of ions. In the above activity, it was found that the aqueous solution of the compounds NaCl, CuSO4, H2SO4 and NaOH are electricity conductors. Out of these, NaCl and CuSO4 are salts. H2SO4 is a strong acid and NaOH is a strong base. We have seen that salt, strong acid and strong bases dissociate almost completely in their aqueous solutions. Therefore, the aqueous solution of all these three contains large number of cations and anions. A characteristic of the liquid state is the mobility of its particle. Due to this mobility, the positively charged cations in the solutions are attracted towards the negative electrode or cathode and move towards the cathode. On the other hand, the negatively charged anions move in the direction of the anode. The movement of cation in the solution towards the respective electrodes amount to the conduction of electricity through the solution. From this, you will understand that these liquid or solutions which contain a large number of dissociated ions conduct electricity. Electrolysis. Take a solution of 1 gram copper sulfate in 50 ml of water in a 100 ml capacity beaker. Use a thick plate of copper as an anode and a carbon rod as a cathode. Arrange the apparatus as shown in the figure and pass an electric current through the circuit for some time. Do you see any change? In the above activity, copper appeared to have deposited on the portion of the cathode immersed in the solution. When an electric current started flowing through the circuit, the cations, that is Cu plus ions in the solution got attracted towards the cathode. Cu atoms are formed when electrons coming out from the cathode combine with the Cu plus ions. A deposit of the copper appeared on the cathode even though the Cu plus ions in the solution were used in this manner. The color of the solution remained the same because while electric current was on, electrons were removed from the Cu atom of the anode and sent to the battery through the electric wire. Cu plus ions formed in this manner entered the solution. In this way, decomposition of the solute in the solution took place due to the electric current, and this is called electrolysis. There are two parts in the electrolysis process. These are the cathode reaction and the anode reactions. Electrolysis of water. Now here one activity is given. Dissolve 2 grams salt in 500 ml pure water. Take 250 ml of this solution in a 500 ml capacity beaker. Connect two electrical wire to the positive and negative terminal of a power supply. Remove the insulating cladding from about 2 cm portion at the other end of the wire. These are the two electrodes. Fill two test tubes up to the brim with the prepared dilute salt solution. Invert them on the electrode without allowing any air to enter. Start the current under 6-volt potential difference from the power supply and observe what happens in the test tube after some time. It is found in the above activity that the volume of the gas formed near the cathode is double that of the gas formed near the anode. Scientists have shown that hydrogen gas is formed near the cathode and oxygen gas formed near the anode. And from this, it is clear that electrolysis of water has taken place and its constituent elements have been released. And the reactions are given as follows.